Welcome. In this video, we're going to learn how to add rational expressions. To do this, it's helpful to remember how you added fractions when they were just based on numbers. So to add fractions, our denominator, which is the bottoms, must be the same. When we add, our denominators do not change. So we're going to keep the bottom the same, and we're going to add the values on the top. Now, one thing that's special when we have variables is that our bottom cannot be 0 because that would make it undefined. Try it on your calculator. 5 divided by 0 will give you an error. So let's go ahead and let's add 3 over 2x plus 5 over 2x. We can add those together because our denominators are the same. This gives us an answer of 8 over 2x. which we could actually simplify down to 4 over x. And remember, our bottom cannot be 0. So in this case, we would say that x cannot equal 0. Let's try this one. X minus 1 over 2x minus 3 plus negative 5x plus 2 over 2x minus 3. Okay, we have a common denominator, so we can go ahead and combine the tops. So x minus 1 plus negative 5x plus 2 will all be divided by 2x minus 3. I can go ahead and combine like terms on the top. So x minus 5x will give me negative 4x. Negative 1 plus 2 is plus 1. And my bottom is 2x minus 3. Now remember, our bottom cannot equal 0. So 2x minus 3 cannot equal 0. What x value would make that happen? So I'm going to say 2x minus 3 equals 0. I would add 3 to both sides. So 2x equals 3. Divide both sides by 2. So when x is equal to 3 halves, our bottom would be 0. That's not allowed. So we're going to say that x cannot equal 3 halves, or 3 over 2. Now, what happens if our fractions do not have a common denominator? We need to find them, and we're going to find it using the least common multiple. To do this, we're going to start by factoring. When we factor x squared minus 3x minus 4, remember, we are looking for two numbers that multiply to equal negative 4, but add to equal negative 3. That would be x minus 4 and x plus 1. Now let's factor x squared plus 3x plus 2. I need numbers that multiply to equal 2, add to equal 3. That factors as x plus 2 times x plus 1. Now, our least common multiple, we're going to list all the factors between the two of them. However, if a factor appears twice, once in each time, we're only going to list it once. So for example, I notice that both of these have a factor of x plus 1. So when I'm looking for my least common multiple, I will only include x plus 1 once. So listing them down, I would have x minus 4 times x plus 2 times x plus 1. That is my least common multiple. Let's try another one. Let's find the least common multiple of 9x squared y and 6xy cubed. I'm going to start by factoring 9x squared y. Well, 9x squared y is 3 times 3 times x times x times y. 6xy cubed is 3 times 2 times x times y times y times y. Now I'm going to go ahead and I'm going to look for matching pairs. I notice that both of these have a 3. So when it comes down to it, I'm only going to list that 3 once. Then I see that, oh, there's an X in both of them. I'm going to do that a different color. So X appears once in both. And then I notice that I also have a Y that appears once in both. Okay, now I'm going to list all of my factors, but I'm going to make sure that I don't double list the ones that are highlighted. So it might be easiest to go ahead and write down the ones that are not highlighted. So I know I'm going to include that non-highlighted 3, the non-highlighted X, 2, and then I have 2 Y's that are not highlighted. Okay, now of the highlighted ones, I'm only going to include one of each pair. So I had the 3's that appeared in each, so I'll have another 3. I had another X and another Y. Let's see what that simplifies down to. Multiplying my numbers, 3 times 2 times 3 is 18. Then I'm going to have X to the second power because I have X written down twice. So I have X and X, so that's X squared. And then I have Y to the third power. So my least common multiple is 18x squared times y to the third power. Now again, let's apply this to adding fractions. To add our fractions, we need to have a common denominator. Look at this example. 2x plus 5 over x squared plus x minus 6 plus 3x divided by x minus 2. Right now I do not have common denominators, so I can't add them. To find our common denominator, we're going to start by factoring the denominator. So to factor x squared plus x minus 6, remember I am looking for two numbers that multiply to equal -6, but add to equal 1. So in factored form, that would be x minus 2 times x plus 3. The second denominator, x minus 2, cannot be factored. So to find the least common multiple, I'm going to use these factors. Now I notice that x minus 2 is a factor in both of them. I'm only going to use that once, but then I do have the x plus 3. So my least common multiple is x minus 2 times x plus 3. And it's okay to leave that in factored form. So I want that to be the denominator of both of my fractions. Well, I know that is already the denominator of the first fraction, but I need to make it the denominator of my second fraction. So I'm going to look at 3x over x minus 2. I notice the part that it's missing is the x plus 3. So I can multiply the top and the bottom both by x plus 3. Multiplying the top and bottom by the same thing does not change the value. So I'm going to go ahead and multiply that. So 3x times x plus 3 is going to give me 3x squared plus 9x divided by x minus 2 times x plus 3. Now I have a common denominator. I can go ahead and add this. So I just rewrote the problem. The first fraction was 2x plus 5. And then I wrote my denominator in factored form. So that was over x minus 2, x plus 3, plus my second problem. Once I multiplied the top and the bottom by x plus 3, I had 3x squared plus 9x over x minus 2, x plus 3. Now let's go ahead and we're going to add the tops, and our bottom is going to stay the same. So on the top, I will have 2x plus 5 plus 3x squared plus 9x all over. My bottom will still be x minus 2, x plus 3. We're going to simplify down the top by looking for like terms. So 2x can be combined with a 9x, and I'm also going to write this in standard form. So my biggest exponent first. So 3x squared plus, combining my x's, 11x plus 5 all over x minus 2, x plus 3. But wait, we're not quite done. Again, remember that our bottom cannot be equal to 0. So while this is my answer, I have to clarify what values would make the bottom equal to 0. So we can set x minus 2 equal to 0. If x minus 2 is 0, that would mean x is 2. So x cannot be equal to 2. Also, x cannot be equal to negative 3. Let's try one last problem. X plus 2 divided by x squared minus 2x minus 15 plus x over x plus 3. I have to begin by factoring the first denominator, x squared minus 2x minus 15. I am looking for two numbers that multiply to equal negative 15, add to equal negative 2. So the factored form would be x plus 3 times x minus 5. Now the nice thing about this is you'll notice that x plus 3 was also a factor of the second fraction. So my least common multiple is going to be that first denominator of x plus 3 times x minus 5. Now, if we want the second fraction to have the denominator of x plus 3 times x minus 5, that means we're going to need to multiply the second fraction by x minus 5 in both the numerator and the denominator. So x over x plus 3 times x minus 5 over x minus 5. That gives us the top of x squared minus 5x. And we can leave the bottom in that factored form, x plus 3 times x minus 5. Now we're ready to add because we have a common denominator. So rewriting this problem, my first fraction did not change at all. X plus 2 over x plus 3 over x minus 5. That's the same denominator, just in factored form. Plus, the second fraction is equal to x squared minus 5x over x plus 3, x minus 5. So now we can go ahead and add the tops, leave the bottom the same. X plus 2 plus x squared minus 5x all over x plus 3 times x minus 5. We're going to combine our like terms in the top and also put my x squared terms first. So x squared minus 4x plus 2 over x plus 3, x minus 5. But don't forget, we need to identify what values will make the denominator equal to 0. So if x plus 3 was equal to 0, that would mean that x was equal to negative 3. Or if x minus 5 was equal to 0, that would mean that x was 5. Those values are not allowed, so we would say x cannot equal -3, and x cannot equal 5. Thanks for watching. Make sure that you read the hints that are in your worksheet as well. And no, we're going to practice this again in a couple of assignments.